Okay, let's get to it. Now we are going to turn the z-score formula on its head. The z-score formula, if you recall, is x minus mu divided by sigma. Today we're going to take that formula and we're going to solve for x. But before we get to that, let's get to example 1. Determine the value of z if the area to the left of z is 0.8621. Alright, so you might look at that word, that question, and say, what are they even talking about? Alright, so let's start with this. Think about how much area is to the left of this center line. Would you all agree that half, or 0.5, is to the left of that center line? So we need to draw a line so that the area to the left of it is 0.8621. With a little bit of thought, I'll bet you'd figure out that that line is somewhere over here. So think about this. The area to the left of that line has to add up to 0.8621. Oops, there we go. All right, but wait, a little bit of thought. There's already 0.5, or half of the graph in terms of area to the left of the center line. So that leaves 0.3621 in this area right here, because that would add up to 0.8621. All right, so what we need to do is we need to look at the z-table and look up this area backwards. In other words, we're going to find the z-score that is associated with 0.3621. I need all of you to get your z-tables out. Now I need you to look in the 4-digit area section of the z-table and find the area 0.3621. I'm looking myself right now. I wish I could bring the screen up, but I'm working on that. Getting another video capture app. I found it. It is to the far right. Go down to 1.0 and go across to 0.09. Does everybody see 1.09 z-score? Do you see 0.3621? So the z-score associated with an area of 0.3621 is a z-score of 1.09. And congratulations, you've just answered example 1. Alright, so now let's get to example 2. Now we're getting into the big questions here. Here we go. Executives decide to discontinue production for the tallest and smallest 7.5% of the adult population. To find the minimum and maximum heights if they will produce a mean of 70.2 inches and a standard deviation of 4.2 inches. Okay, so right now I am going to put that mean of 70.2 inches right here in the middle, and I am going to note that my standard deviation is 4.2 inches. Alright, so I'm going to cut off, apparently, due to whatever budget restrictions, 7.5% on the top and on the bottom. How do you write 7.5% as a decimal? Isn't that 0.075? And down here is another 0.075. Right? Hey, but what I'm really interested in is the area from the center out to this, because that's what my z-table measures. So if I do 0.5 minus 0.075, I get 42.5%, or 0.4250, and another 0.4250 here. Okay, this is what I'm going to look up backwards on my z-table. I need you all to look at your z-table and try to find 0.4250. Unfortunately, you won't find that area exactly, will you? But if you go down to 1.4 and you go across to 0.04, in other words 1.44, you'll find an area of 0.4251. Here's what you need to do. You need to find the closest area on the z-table to what you're looking for. And in this case, the closest area is 0.4251. And the z-score associated with that is 1.44. Down here, since this is to the left of the mean, oh, by the way, these are raw scores, and these are the z-scores. Ultimately, we're looking for this maximum value right here, and we're looking for this minimum value right here. That's the max, that's the min. And the z-score associated with this minimum value is negative 1.44. Do you all understand? Positive z-scores are to the right of the mean. Negative z-scores are to the left of the mean. Okay, so now how do we find this max and this min value given this information right here? That's where the z-score formula comes in. The z-score formula, once again, is x minus mu divided by sigma. Okay, without actually showing the algebra, if you multiply both sides of this equation by sigma and by sigma, I guess I am showing it. All right, you would get x minus mu equals z times sigma. Then you would add mu to both sides. And so there's your solution for x. X equals the mean plus the z-score times sigma. So, to find the minimum and the maximum, let's find the maximum first. To find the maximum, I'll just call it the max x. I'm going to take the mean of 70.2 plus the z-score, which is 1.44, times sigma, which is 4.2, and I get a maximum of, let's see if I plug that in, what will I get for my maximum? 76.248. That's my maximum, 76.248. Now, to find my minimum, I take this same formula over here. The z-score, just solve for x. All right, to find my minimum, I take 70.2, now minus the 1.44 times 4.2, and my minimum is going to equal 64.152. And that's what goes right here, 64.152. Not bad, right? You're just taking the z-score formula that we used last lesson, you're solving it for x, and you're plugging in all the values that you know to find the whatever raw score you're looking for. But did you notice, before we could find any raw scores, you needed to find the z-score that was associated with the area from the center out to that point. That's the biggest part about this lesson. You need to find the area from the center of the curve out to wherever you're looking, then find the z-score associated with it, and then you can plug everything in and find whatever value you're looking for. One more example and we're done with the lesson. Here we go. College entry. A college requires an entrance exam score that is among the top 70% of all scores. If the mean score on this test is 500 and the standard deviation is 100, find the minimum acceptable score. All right, so mu is 500, sigma is 100. I'm going to put 500 smack dab in the middle. Now, think about this, the top 70%. I mean, schools like any Ivy League school might only take the top 10% of students, or the top 5%. So, and also just think about it, this is the top 50% right here to the right of the center line. So a line that would accept the top 70% must be down here somewhere, where 70% of the scores are above this line, which means 50 plus, wait for it, 20 adds up to 70. But you know what I do? I write 0.2000. You know why I write my area in as 4 decimal places? Because my z table measures the area, displays the areas using 4 decimals. So I need you all to look up the closest z-score to 0.2000. Do that right now. I'm going to do it myself. Here's my paper. So I don't know about you, but I went down to 0.5, and I'm looking at 0.52 and 0.53. Look there with me. I see 0.52 is 1985, 0.1985, and then a z-score of 0.53 is 0.2019. I'll even write that. A z-score of 0.52 is 0.1985, and the z-score of 0.53 is 0.2019. So this is 15 units away from 0.2000. This is 19 units away. So you know what? Ding, 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 ding. This is the winner. So that means this is the winner, 0.52. So I'm going to write a z-score of 0.52. But wait, it's to the left of the mean, so it's got to be negative 0.52. Do you follow? So we're looking for this mystery value right here. What is that entrance exam score? Well, let's figure that out. I know that x equals mu plus z times sigma. So I'm going to do x equals 500 minus the 0.52 times 100. So that's essentially 500 minus 52, which is 448. And ladies and gents, if you haven't figured it out yet, these are SAT scores with a mean of 500 and a standard deviation of 100. So to get into this particular school, you need at least an SAT score of 448 to get in. And that, my friends, is the end of this lesson. You are using your Z table backwards. You are looking up an area to then find the Z-score that matches that area most closely. Then you're using that Z-score and plugging it into the Z-score formula and solving for X. All right, if you have any questions, message me.